All right, so the next thing we're going to work on is average value of a function. Here's the deal, guys. It's a pretty simple fact. So we've got some function. Let me give you this crazy function. So we've got some function. Here's x and here's y. And we've got some crazy function that goes up and down and up and down, kind of like the stock market. And it goes up and down and way over and whatever. And so from some point A to some point, let's say here, B, we want to know what is the average y value. What is the average y value for this function? Okay, what is the average y value? What is the average height? Okay, so we've got a peak here, we've got a valley down here, and another peak here. But we want to know the average height all the way across. And so here's the concept. Okay, here's the concept. We know from A to B, we've got, use a highlighter here, we've got this area, right? We got this area, okay? Is that fair? So we got some area, okay? And the way we find the average height, we call it y average, okay? The average height. The way we find this is we kind of create a rectangle, okay? So let me draw this out for you. We got some average height, and we know the distance from A to B because A and B are going to be some number, okay? So here we've got this function, f of x, and we know this area is equal to the integral from A to B of f of x with respect to x, okay? And so what we're going to say is we're going to say that that area, that integral, which has some area to it, right? That integral has some area to it. That integral is going to be equal to a rectangle. And the area of a rectangle is going to be length times width. Length times width. Okay? Well, the length is going to be b minus a. It's going to be our horizontal distance. And the width is going to be our y average. Okay? Y average is the height of this rectangle. So now we have an equation. We have an equation that says the integral from A to B of f of x dx is equal to b minus a times y average. Okay? So we've got this equation. And all we're doing is we're saying, let me go back, make sure this is clear, that this in yellow, this zone in yellow, which is the integral, the area under the curve, is equal to the area of this rectangle, right? So the, let me write that out. Make sure everybody's got that in their notes. Area under the curve is equal to the area of this rectangle that we've created. Okay, we assume that to be true. Okay, and now if we want to find y average, we got to solve for it. So solve for y average. Okay, how do we do that? Well, the first thing we got to do is we got to divide by b minus a. Or another way to say it is to multiply by the reciprocal of b minus a. So this left-hand side becomes 1 over b minus a times the integral from a to b of f of x dx. And that's equal to y average. Okay? And this is a theorem in your textbook. Okay? And so anytime you want to find the average height or the average function value, the way you're going to do that is you're going to use this equation. So, well, let's try one. Okay? So, find y average for f of x equals x squared minus x plus 1. Okay? And so if we take our, and they have to give us a integration zone or an interesting point or something. So from 0 to 2. Okay? From 0 to 2. Okay? So we're going to take this guy and we're going to use this formula. So we're going to say y average, this theorem, 1 over b minus a, b minus a times the integral from a to b f of x dx, which is equal to 1 over, right? 1 over, and let's go back to our original equation, right? From a to b, so this will be a, and this will be b. So a is 0 and b is 2. Okay, so in this case, we got 2 minus 0 times the integral of what? 0 to 2 of our function x squared minus x plus 1 dx. Okay, now we've got to, so we've plugged in our numbers. Well, this guy here, this fraction, just becomes what? Just becomes 1/2 times the integral. Okay, well, let's go ahead and do our integration here. Integral of x squared is going to be 1/3 x cubed. And the integral of negative x will be 1/2 x squared. And then the integral for 1 will be plus x. And this will be evaluated from where? 0 to 2. Okay? So now we need to evaluate our integral. And this 1/2 is just a constant, so it's going to stay outside this entire time. So we get y average is equal to 1/2 times. Now, what have we got? We're going to have our first piece here, which will be the 2. So this will be 1/3 times 2 cubed minus 1/2 times 2 squared plus 2 minus, and then we come in here and we're going to get what? 1/3 times 0 cubed minus 1/2 times 0 squared plus 0. Well, that whole big thing over here is just 0. So that's pretty easy. We don't have to do anything with him. Okay? And this guy here comes out to be 8/3. So this here comes out to be 8/3. And then, of course, we have to multiply by 1/2. And so we get y average is equal to 4/3. Now, all that means is if you were to graph this, okay, and that's the important part, if you were to graph this. So let me go ahead and graph this. So if we graph this, right, from 0 to 2, and the function we were graphing was x squared minus x plus 1, okay? So it's going to be some kind of parabola, okay? It's going to be some kind of parabola. So let's say that parabola looks something like that, right? What we're saying here is if you drew a, let's go to red first, okay? So that area in red is equal to this area in green. Okay, the area in red is equal to the area in green, and that area in green has a height of 4/3. Okay, that's all that's saying. It's the average function value from 0 to 2. Okay, and it's actually a quite handy thing. Like if you look at the stock market or if you look at interest rates, things like that, you can say, okay, well, we averaged an 8% rate. We averaged a 12% rate. We averaged a 3% rate. In reality, the rate was going up and down, up and down, up and down, up and down, up and so the rate was going like this, up and down, up and down, up and down. But that average rate, right? That's our average rate. Okay, so it works for a lot of things in business, in finance, in engineering, and in biology. So why? Because this is an ever-changing value, and we need a singular value to plug in. And so we use the average rate. Okay, all right. So if you have any questions about that, let me know. And I'll put up one more video that has a few examples of both of these things and let you guys go at it.